So I cannot stress enough that signs matter when dealing with mirrors and lenses. This is typically anywhere from 1 to 3 questions on any type of exam or assessment. And by not knowing the concept of mirror and lenses is typically what the issue is. So going back to this screenshot that I have posted, as well as a video about this for the mirror and lens equation, you have to know the difference between concave and converging lenses, concave mirror, converging lenses, the 5 locations an object will be, and then as a result, what the image will be overall. And then for a convex mirror, diverging lens, there's only one thing that can occur. And I go over this in great detail in that mirror and lens equation video. Now, for an example, an object is located, and by the way, this is basically a variation of a past exam question. The reference, by the way, is fall 2011, exam 2, question 27. I just changed some numbers. Well, there's only one number to change here and the question. An object is located 30 centimeters from a mirror that forms a real image. So an object is 30 centimeters from a mirror. It forms a real image 3 times the size of the object. 1/object plus 1/image equals 1/focal length. I realize that you might be dealing with DO and DI. However, your formula sheet has S and S prime for this term. Magnification is negative S prime over S. So here we go. We know that the object is 30 centimeters. We're going to keep it all in centimeters for the purposes of this question. And it forms a real image. So first of all, is it concave or convex? Well, the only way you can get a real image is if it is a concave mirror. A convex mirror only gets you a small virtual upright image. Convex mirrors, think about those mirrors you see in like a CVS or a Walgreens. Those are usually, you see yourself, it's smaller, it's upright, and it's actually a virtual image. Now, back to this question. So you know it's going to be a concave mirror. Next up, magnification here. So it says 3 times the size of the object. So you may put, okay, so it's 3. But then the problem is you would say that S is equal to, or 3S is equal to S prime multiplied negative over. And S prime is negative. Because if S here is 30, S prime is negative, and negative means virtual, but we have a real image. And this is where you have to know the only way to get a real image is if it's inverted. Again, the only way you get a real image is check it out. All the real images you get, if you actually solve this all out, is going to be inverted overall. So you had to know it was -3. Again, this is why sign conventions matter. Let's see. So now we have S prime is 1/30 plus 1/3S, so 3 times 30 is equal to 1 over the focal length. Solve for the focal length F. Where's my calculator? 1 divided by 30 plus 1 divided by 90. And the focal length is 22.5 centimeters. The radius of curvature is always double the focal length. So if they ask for the radius of curvature, that's 45 centimeters. And the only way you get a real image that's 3 times the size of the object is, as a way to check if you know your rules, is to get a real image that is larger. That means that it actually has to be in position number 3. The object has to be located between the radius of curvature and the focal length. Again, the object originally has to be between the radius of curvature and the focal length. So to check this, let's go ahead and say S, F, and R. R is 45, F is 22.5, and S was 30, and that does check out. So I'm confident everything was done correctly. Make sure you know your signs, make sure you know your conventions for mirrors and lenses.